Okay, welcome to Electrical Machine 1 lecture. This is lecture number 25. In the previous lecture, some important relation has been derived. Now today we will discuss that points, highlights of this last lecture and important parameter or important equation which we have derived in the last lectures. So first point is that transformer is available in step up and step down, single phase as well as three phase transformer. We can make auto transformer either in step up and step down category. At the same time, this can be used in the single phase and three phase. That is, we can make three phase transformer, three phase auto transformer and single phase auto transformer. So this is our first point. Second point, that the auto transformer kVA rating is greater than the two winding transformer. If suppose we have a two winding transformer, and this two winding transformer is converted into the auto transformer, means a two winding is connected in a series to make a single winding, and step up or step down we can make it. So the kVA rating of auto transformer is greater than the two winding transformer. Let the kVA rating of transformer is 2 kVA. Then when it is converted into the auto transformer, then auto transformer kVA rating is greater than the 2 kVA. Okay, and this is depend upon the voltage ratio. Say this is 200 volt and it is 100 volt. So what would be the kVA rating? So the kVA rating of auto transformer is two type. One is the kVA transform and plus kVA conducted. So therefore the kVA rating of auto transformer is greater than the kVA rating of two winding transformer. So this is the second conclusion and second important point for the auto transformer. Now kVA rating of auto transformer is the relation is 1/1 minus ratio, that is V2/V1 into kVA rating of two winding transformer. Let step down transformer, if we have a step down transformer, then V2/V1 definitely it is less than 1. For example, V1 is equal to 2 kVA and V2 is equal to 100 kVA. So it is 100 kVA and it is 200 kVA. So what would be the kVA rating of auto transformer when the two winding transformer is converted into the auto transformer? Then kVA rating of auto transformer is 1/1 minus V2/V1. What is V2/V1? V2 is 100 and V1 is 200. So definitely it is 0.5 multiplied by kVA rating. Therefore, it is the two time kVA rating of two winding transformer. Let the kVA rating is given as a 2 kVA. Then the auto transformer kVA rating is equal to 4 kVA. Isn't it? 2 kVA is because of the transformer action, and whereas 2 kVA is for the kVA conduct. Okay. Suppose V1 and V2, the relation is, let the relation is, say it is 400 volt and it is 100 volt. So it becomes 1/4. Okay, and 1/4 is equal to 0.25. So 0.75 is there, isn't it? So 1/ minus this one. So under such condition, whatever the rating is equal to the kVA rating of the transformer, isn't it? So this is the meaning. Larger the voltage ratio, what would be the kVA rating? Let it calculate it. Say 1/4. So it is so it will be 1.33. So under such condition, the kVA rating will be 1.33 times the kVA rating of two winding transformer. So this is for the step down. Now what is for what would be the relation for the step up transformer? Like step up transformer where V1/V2 is less than 1. That is the transformer is instead of this one, the transformer is primarily is a 2 kV, a 2 winding transformer whose primary voltage is 100 volt and secondary voltage is 200 volt. Okay. So under such condition, the KVA rating of transformer is equal to 1 upon 1 minus V1 upon V2. Here it is V2 upon V1. So under such condition, again, it is say for that one, the 2 times the KVA rating of the transformer. So simply the KVA rating of auto transformer is equal to 1 upon 1 minus V1 upon V2 or V2 upon V1. But it should be in such a way that the KVA rating is greater than the 2 winding transformer. So it is 1. So this is the meaning that the KVA rating of auto transformer is always greater than the 2 winding transformer when it is converted from 2 winding transformer to the auto transformer. Okay. Now, next very important is that volume of copper for auto transformer divided by volume of copper for 2 winding transformer, and the relation found is equal to 1 minus 1 upon A. Okay. Now see here, in case of single winding transformer, that is a auto transformer. Say this is the, I will draw with respect to the thickness. Say this is the step down transformer, step down auto transformer. It is V1. This current is I1. This current is I2. It is N1 minus N2. Okay. And total number of turns is N2. Here it is V2. Total number of turns for the secondary side is N2. Now, under such condition, the current is equal to I2 minus I1. So it is quite clear that when the current is difference of these two values of the current, definitely the current in this winding is very small. And when the winding resistance is small, winding current is small, definitely we require the thinner conductor as compared to thick. This part is the thicker conductor. So the one winding required a small thickness, second winding required some higher thickness, isn't it? And there is only one winding. So under for the auto transformer, we can save the copper required as compared to the 2 winding transformer, isn't it? So the copper of volume of copper or volume of conducting material is smaller than the 2 winding transformer. This is one part for the material. Second, since core material can be reduced, so here the cost and the size of auto transformer is smaller than the 2 winding transformer. So there is a saving of iron material, there is a saving in the copper material. Definitely, when there is a saving in iron and copper material, there is a reduction in iron losses and copper losses. Hence, the efficiency of auto transformer is slightly greater than the 2 winding transformer. No doubt, we are comparing the at equal KVA rating of the transformer. Okay. Next, what is the relation? Volume of copper for the auto transformer, volume of copper for auto transformer divided by volume of copper for 2 winding transformer is equal to 1 minus 1 upon A. So what is A? A is the turns ratio, N1 upon N2 or A1 upon A2. For example, it is a step up transformer where A is greater than 1. Let A is equal to 2, that is 2:1 ratio. Okay. Now when 2:1 ratio is that, so what is the value? So it is a 1 minus 1 upon 2. So it is a 0.5. So we can say that here the volume of copper for auto transformer is equal to 2 times, or it is a say 1 minus point, it is a 0.5 time 0.5 times volume of copper for two winding transformer, isn't it? Means 50% copper is needed when the voltage ratio is 2:1. It means that what is the saving then? What is the saving? Saving of copper is equal to 0.5% is the 50%. So their saving is 50%. Let me consider that this is the auto transformer, and under such condition, instead of 50%, we take only the ratio is very small, ratio is higher one. Say it is a 400 volt and it is 100 volt. Means the ratio is 4:1. See what is the volume of copper required. So volume of copper for auto transformer is equal to 1 minus 1 upon A. A is equal to, here 4 upon 1 is 4, it is 4. So 1 minus, it is 1 upon 4, it is 0.25 multiplied by volume of copper for two winding, isn't it? It means that it is a 0.75 times volume of copper for two winding, isn't it? Volume of copper for two winding. What it means? What is the saving? 0.75% is needed. So what is the saving? Saving is equal to same ratio, isn't it? The saving is 75%. Okay. So here we can say that if the difference is smaller, the difference is more, we can get the, sorry, here the saving is, we can say that, therefore the saving is equal to saving saving is equal to 75%. Saving is equal to 75% saving we can get. Sorry, it is a 25%. Okay, so saving we can get the in this way we can get the saving is equal to 25%. Okay, so these are the, that is, in short, there is a saving of copper in case of auto transformer. So these are the advantage. First advantage is that it is available in step up, step down in three phase as well as single phase. Second, the KVA rating of auto transformer is greater than the KVA rating of two winding transformer, because the transformer KVA is equal to due to the transformer action, due to this transformer action plus KVA conduct. Now KVA of auto transformer is equal to this ratio and this formula, and therefore we can calculate the KVA rating of transformer as compared to the KVA rating of two winding transformer. And the fourth point is very important, as the saving of copper is there. So because of this number of advantage, we say that the volume of conducting material, volume of say iron material is less, hence the efficiency of the auto transformer is slightly greater than the two winding transformer. So because of this advantage, why we are, the question comes in our mind is that that can we replace the three-phase distribution transformer by a three-phase auto transformer? So our distribution transformer, distribution three-phase transformer is generally, say for example, it is 11 kV by 415 volt, isn't it? Is it possible? Yes. Is it possible we can make the three-phase auto transformer whose ratio in such a way that the primary winding is 11 kV and secondary winding is 415 kV? But we are not using three-phase auto transformer in the distribution network, as well as in the single phase also, where we need continuous application is like that. There is a 6600 volt and the secondary voltage is only 415 volt. Or it may be a say for example, it is a transformer, single phase transformer, which is a continuous use, needed 110 volt, and here it is a 230 volt. We are not using, because many of the control circuit or measurement circuit, as well as in protection circuit, we need the secondary voltage is 110 volt, because we are using instrument transformer is 230 or 400 by 110 volt for protection circuit, as well as some measuring circuits are there, isn't it? So the reason is that even though there is a saving of copper, there is a rating of auto transformer is greater. The reason is that let me examine this comparing two winding transformer and auto transformer. It is very important. Just do this lecture very carefully. Say this is two winding transformer, and it is connected to V1 source is connected here. Is a higher voltage, say it is a 230 volt, or it may be say higher voltage. Again, instead of this one, we'll say it is a 11,000 volt is there, and the secondary voltage is 400 volt, okay, or 450 volt. If suppose there is some open circuit in the primary winding or in the secondary winding, there is a open circuit has been occur because of the fault and because of something is there, is a open circuit. What will happen? The secondary voltage V2 is equal to becomes 0, isn't it? Only the primary winding will remain connected to source. Now consider the same ratio of auto transformer. So definitely there is a large number of turns in the say upper section and few number of turns in the lower section for the secondary voltage. Here we are getting 400 volt with the help of auto transformer, and the primary voltage is 11,000 volt. Okay, this is the case over this one. Now same fault is occur here. Same fault is occur here is that there is a open circuit in the secondary winding because of fault or because of any reason. So what will happen? Instead of 400 volt, the entire 11 kV is going to appear across the secondary winding. Are you getting? Because of opening in the secondary winding terminal, rest of the primary voltage is going to appear across the secondary winding, and where 400 volt is needed, and it is going to create nearly 11 kV. And definitely whatever the instruments, whatever the equipments are connected on the secondary of auto transformer is going to burn out or is going to damage. So there is no isolation. So the disadvantage is no isolation. So because of this very important reason, any fault in the secondary winding, in the two winding transformer, the voltage V2 goes to the 0 value. There is no say such a harm, or the people those are working on such a circuit, because our secondary circuit is designed, the insulation is designed only for 400 volt, whereas in this case again we are using the equipment which is designed at 400 volt, And when 11 kV is going to appear, definitely the insulation and the windings, as well as the person who is working on the secondary of the transformer, is loss of property and loss of life is there. So this is the main reason that there is a disadvantage. This is the limitation. That's why we are not using auto transformer in the distribution network or in such application. Second disadvantage of distribution transformer, disadvantage of auto transformer is that auto transformer have low percentage impedance. When there is a low percentage of impedance, therefore the short circuit current, whenever there is a short circuit occur, the short circuit current is very high. So very high short circuit current is going to flow under the fault condition. This is the one more disadvantage in the auto transformer is that, and hence the auto transformer is not used for the continuous application. Definitely it can be used for the some, say for example, it may be used in the laboratory for varying the voltage and for this one. So the effective per unit impedance or percentage per unit impedance is small, and hence the short circuit current is higher one. So under such condition, the application of auto transformer is used for the to boost the voltage. It is used for the laboratory application for variable output we can get. And the third is we can use for the star auto transformer starter, three-phase, for the three-phase induction motor. So under such condition, the auto transformer is tapped with a different tapping, and this is used for the to make the auto transformer starter. It is used as, it is called as a auto transformer starter for three-phase induction motor. So this is the theoretical part of auto transformer, and it is very important to understand what is the basic idea of auto transformer. Okay. Now let we have a example. Example is like that. 11,500 by 2,300 volt transformer. Transformer is rated at 100 kV. It is a it is 100 kV. 100 kV as a two-winding transformer. This is two-winding transformer rating. If the windings are connected in series to form the auto transformer, calculate kVA rating and copper saving as the load is connected to 11,500 volt, also on 2,300 volt. So there is a two way to connect. It is given as, say, first part we will take. These two windings are connected in series to make the auto transformer. Where the load is connected to 11,500 volt circuit. So here it is a V2 is equal to 11500 volt, whereas the winding is connected in a series, so it is 11500 volt, and here it is a 2300 volt. So the total voltage V1 is equal to addition of these two values. It is 13800. Okay. Now this is the current I1. This is the current I2. Okay. Definitely it is A smaller voltage on the secondary side, it is I2 minus I1. Okay. This is I2 minus I1. Here it is V2 minus V1. This part is A, this part is B, this point is C, and it is N2 minus N1. Okay, this is the case on this way. Now, definitely, as it is connected in series, so dot mark is very much necessary. This is one, then and then it is possible that both are in series, and it is possible to add these two voltages, that is V1 and V2. Okay. Now, first solution, first we will calculate the high voltage if it is a two-winding transformer. When it is a two-winding transformer whose voltage is 1100 volt, and here it is a two-winding transformer. Earlier it is a two-winding and it is get converted into this one. It is 2300 volt. So this current will be, say, IL LV current, and this will be the HV current. Okay, so HV current is equal to kVA rating multiplied by 10⁻³ divided by the voltage. It is 11500, and the value of HV current is 8.69 ampere. Similarly, LV current IL is equal to 1000 into 10⁻³ divided by 2300 volt, and it is equal to 43.48 ampere. This is the two currents is now calculated for the two winding transformer. The current in the transformer, auto transformer winding will remain same. So this current, definitely this current, HV current is 8.6 ampere. So it is a 8.69, and this is this current is 43.48. Okay. So kVA rating of transformer, kVA of auto transformer is equal to kVA transform plus kVA conduct. What is that? kVA transform is because of the transformer action. Because of the transformer action, it is VAB into IAB, okay, plus V2, that is VBC multiplied by IAB as it is. So under such condition, the value of auto transformer is VAB, it is 2300 multiplied by 43.48 plus VBC, it is 11500 multiplied by current 43, IABC, it is 43.48. It is equal to 100 kVA is the kVA transform, because the kVA rating is 100, so it is 100 kVA plus kVA conducted is 500, and therefore the total kVA rating of transformer, auto transformer, is 600 kVA. See, the kVA rating has been here increased. kVA auto transformer, when the kVA of the two winding transformer is only 100 kVA, whereas the same two transformer, the two winding transformer is converted into the auto transformer by connecting two winding in series. The kVA rating of auto transformer becomes 600 volt. Okay. Now, voltage ratio. So this is the one part. It is, we got ratio is equal to A is equal to transformation ratio N1 upon N2, V1 upon V2, and it is equal to 1:3. This is the ratio is 1:3,800. divided by, what is the secondary voltage now in auto transformer? 11500. It is equal to 1.2. Okay. So therefore, volume of copper in auto transformer is equal to 1 upon 1 minus 1 upon A into volume of copper in two winding transformer. Okay, this is two winding. It is equal to 1 minus 0.833 into volume of CO. Okay, in two winding transformer. So it means that 1 minus 0.33, it is 0.166 time volume of copper is needed. Volume of CO for two winding transformer, isn't it? So it means that what is the saving? Therefore, saving, as it is only 1, it is 0.166. Okay, 0.166. When the saving, when the copper needed is 16%. So what is the saving? Saving is 83%. So saving of, here it is 1 is 16. So therefore, saving of copper is equal to 83.33%. This is the answer. Okay. Now, B case B. What is the case B? It is asked that in the second case, the voltage, secondary voltage is, now part B, load is connected to 2300 volt. Okay, so under such condition, what would be the this one? It is a very good example so that we can get the conclusion. Again, it is a same, it is connected in series. So here it is now 11500 volt and it is 2300 volt. The secondary load is connected to, at this load condition, at this load, it is a V2, which is equal to 2300 volt. Okay, and this is now N1, N2, A, B, C. This is current I1. This current is I2 minus I1 as it is, isn't it? And this is total voltage V1. V1 is equal to addition of this T13800 volt. Now everything has been calculated. So just it is a kVA rating of auto transformer. kVA rating of auto transformer is equal to VAB, IAB, VA to B into IAB is the by transformer action, VBC multiplied by current conducted IAB, which is equal to 11500 multiplied by 8.69 plus 2300. Okay, say right here it is a 43.48 ampere, whereas the current direction has been changed over this one and it is 8.69 ampere. So multiplied by 8.69 ampere, which is equal to, this is kVA transform, as again it will remain as 100 kVA, whereas the secondary it is become 19.99, say it is, so it is 120 kV. So see here, as the this ratio in the previous case, what is the secondary voltage is higher one. Secondary voltage is 11.5 kV, and here it is secondary voltage is 2.3 kV, isn't it? So if the ratio is smaller, the difference in primary winding and difference in the secondary, with respect to the secondary winding is smaller, the kVA rating also get decreases. So here the kVA rating will be smaller. It means that if the ratio is near to the 50% and more, the kVA rating is going to increase. So this is the case. Now, this is the kVA rating of transformer. You can check by this one. kVA rating of auto transformer. It is equal to V1 I1. What is V1? It is 13800 multiplied by, what is the current I1 here? I1 is 8.69. So again, it will give the 120 kVA, or it is equal to, you may calculate as from the secondary side. So kVA rating of auto transformer is secondary voltage is V2 I2 is equal to then the current in the secondary side would be addition of these two values, 8 point this one and this one, it is 52.17. so here it is secondary voltage is 2300 multiplied by 52.17, again it will give the 120 kVA. So kVA rating of transformer is more. Now how to find the kVA conduct? kVA conduct is equal to kVA of auto transformer minus kVA capacity of two winding transformer, that is because of due to transformation or transformer simply transformer action, and it is equal to 120 minus 100. So we can say that the 20 kVA is due to the conduction, and again he has found here it is here. So here it is found that 100 kVA is due to transformer action or transform kVA transform, and it is a kVA conduct. So by this way, this is the second configuration. This is the second result we found, is a kVA of auto transformer is 120, isn't it? Anyway, we can find if we have a clear fundamental regarding the transformer, definitely we can calculate the volume of copper. Volume of Cu for auto transformer is equal to 1 minus 1 upon A into volume of two winding transformer, isn't it? So it is equal to 1 minus 1 upon A is equal to, or it is say it is equal to 1 minus, instead of what is A? A is here, it is 13800, okay, divided by 2300. So here it is just 1 upon A, it is 1 upon 13800 divided by 2300 into volume of two windings. So it is equal to it is equal to 1 minus 0.8. It is equal to total. This total is equal to 0.833 into volume of copper in two winding, isn't it? So simply we can say that saving is equal to, if the volume of copper required for auto transformer was 83%, so what is the saving? Saving is equal to 1 minus 0.83, it is a 16.66%. Simply the saving is equal to the ratio. Saving is equal to the ratio. See here. Here saving is equal to A is equal to, what is the ratio? It is ratio is 1:3. See here, what is the ratio? Ratio is 13800 divided by 11500. Therefore, the 1 upon A is equal to 0.833. So saving is equal to percentage. Saving is equal to 83%. Simply. Now, in the second case, A is equal to 13800 divided by 2300. The ratio becomes 0.166. Therefore, saving is equal to 16%. So the important conclusion is that if the ratio is smaller, this ratio is smaller and this ratio is greater. Ratio is smaller, saving is more. And ratio is greater, the saving is more. So the transformer, when it is connected to the very large difference, for example, the transformer ratio is like that. It is a 11 kV and here it is a 400 volt. So under such condition, the saving is small. This is the one of the reason is that there is no much more attraction toward the distribution to use as a distribution transformer because the saving of copper is very small. Now, whereas if the ratio is somewhat greater, instead of here, say, we can say that the saving is 16%. Suppose it is a 16%. And if the ratio is in such a way that instead of it is 11 kV and here it is a say 6600 volt. So here maybe the saving is greater, saving is higher. So it's large the difference, saving will be small. So okay, thank you. Next time we will see some other numericals.